Very good morning to all of you. Now we are going to see the topic gram equivalent concept. Gram equivalent concept. The last class we have seen the mole concept. Mole concept requires a balanced chemical reaction to find out the amount reactants involved in the chemical reaction, while gram equivalent concept does not require the same. So actual definition of the gram equivalent mass is mass of an element or that combines or displaces 1.008 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine. I repeat, the gram equivalent mass of an element, compound or ion that combines or displaces 1.008 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine. Okay. In which condition gram equivalent concept is used? In which condition gram equivalent concept is used? We use mole concept for non-redox reaction, but gram equivalent concept for redox reaction. The ion electron concept applied in redox reaction. In that kind of reactions we can use the gram equivalent concept. Otherwise, so in the equation it is not the redox reaction but hydrogen is displaced. The equation is showing the displacement of hydrogen or oxygen or chlorine. In that equation we can apply gram equivalent concept, and a redox reaction we can apply gram equivalent concept. Okay, so in this equation zinc is a metal, reacts with sulfuric acid, it displays hydrogen gas, salt zinc sulfate with hydrogen gas. Okay, so in this reaction 1 mole of zinc, the atomic mass 65.38 gram, displaces 1 mole of hydrogen molecule in the product side. So atomic mass of hydrogen molecule 2.016 gram. Mass of zinc required to displace 1.008 gram of hydrogen. So how to write the zinc mass, atomic mass 65.38 divided by 2.016. the numerator denominator we have written regarding the equation. The numerator metal atomic mass zinc, denominator displacement of hydrogen atomic mass. So multiple with 1.008 gram of hydrogen. Then only we can find the equivalent mass of zinc. 2.016 gram of hydrogen molecule gets from 6538 gram of zinc metal. If so, 1.008 gram of hydrogen atom 1.008 gram of hydrogen atom, how much mass of zinc is required? That is called a gram equivalent mass of zinc. What's the value? 32.69. Here no unit is given because here gram is not mentioned. If you are going to calculate the gram equivalent mass of zinc, means the value with the unit gram per equivalent, we should write it. So equivalent mass has no unit, but the gram equivalent mass has a unit, gram per equivalent. I repeat, 2.016 gram of hydrogen molecule get from 65.38 gram of zinc. If so, 1.008 gram of hydrogen, how much mass of zinc required? That is called gram equivalent concept, mass. Okay, another type of question. What is a gram equivalent mass of sulfuric acid? King of chemicals, sulfuric acid. So in this question, equation is not given, but only acid alone is given. So how to find the gram equivalent mass? First, you should find the basicity. Actually, sulfuric acid is an acid. So in which we have to find the basicity. How to find the basicity? How many hydrogen is replaced by base OH minus? What is acid? Donating H plus. Donating H plus is called acid. So sulfuric acid molecular formula H2SO4, it donates 2 hydrogen. When base reacts with the acid, 2 hydrogen is replaced. So hydrogen 2 hydrogen, so 2 equivalent per mole. That is a basicity. So molar mass of sulfuric acid, first you should calculate molar mass of sulfuric acid, because so what is the formula for gram equivalent mass of sulfuric acid? Molar mass of the acid divided by basicity of the acid. Basicity already we found, that is 2. So molar mass of the acid, how many hydrogen? 2 hydrogen. 2 multiple with 1. relative atomic mass of hydrogen 1. Sulfur atomic mass 32. So how many sulfur? 1 sulfur. So 1 into 32. Oxygen atomic mass 16. So how many oxygen? 4 oxygen. 4 into 16. So totally 98 gram per mole. So 98 molar mass of the acid divided by basicity of the acid 2. So we can get gram equivalent mass of sulfuric acid 49 gram per equivalent. Okay. So in the question, equation is not given, acid only is given. The acid we can find itself the gram equivalent mass. So another type of question. So in the question, what is the gram equivalent mass of base? Here acid is not given, but base is given. So definition, the ratio of molar mass of the base divided by acidity to the acidity of base. Okay. KOH is a base. How can we say it is base? Donating OH minus. Donating OH minus, that is base. KOH is a base. So KOH acidity, how many OH is replaced by acid H plus? Only 1 OH. So the acidity, KOH acidity, only 1. The previous slide, basicity of the acid we found it. Here acidity of the base we should find it. Only 1. Only 1 OH is replaced by acid. So molar mass, the numerator we have to calculate. How many K? K means potassium 39. So 1 into 39 plus how many oxygen? Only 1. So 1 into 16 plus hydrogen only 1. 1 into 1. Total 56 gram per mole. So 56 divided by 1 equivalent gram equivalent mass of KOH 56 gram per equivalent. So another type of question, what is the gram equivalent mass of the following equation? Here equation is given. So already I told you the gram equivalent concept we can apply in the redox reaction. Redox reaction. This equation, this chemical reaction is a redox reaction. Ion electron concept are present. Here the potassium permanganate KMnO4, the K is removed, K charge plus 1, the K is removed, that's why whole charge minus 1. In the acidic medium 8H plus, H plus means acidic medium. Then 5 electron gives manganese charge 2 plus 4 water molecules. Okay. Here for the equation we should write the statement gram equivalent mass of potassium permanganate equal to molar mass of the oxidizing or reducing agent. Molar mass of the oxidizing or reducing agent divided by number of moles of electrons gained or lost by 1 mole of the oxidizing or reducing agent. Here KMnO4, potassium permanganate is used. We have known very well KMnO4 is a oxidizing agent. Oxidizing agent. Okay. So here 8 plus 8 electrons. 8 electrons. MnO4 whole charge minus 1 electrons. So minus 1 electron plus 8 electron plus 7 electron. Plus 7 electron. Total plus 7 electron. Here 5 electrons is required. Then only is equal to 2 electron. I repeat again. Here minus 1 electron. Whole charge minus 1 electron. 8H plus 8 electron. So minus 1 electron plus 8 electron. Here minus 5 electron. 5 e power minus 1. So 5 into minus 1 minus 5 electron. Totally minus 2 electron equal to minus 2 electron is not there plus 2 electron equal to Mn2 plus 2 electron. So left side right side are balanced. So 5 electron is required. 5 electron is required. Okay, number of moles of electron or gain 5 electron. 5 electron. Okay, here the molar mass of the oxidizing agent KMnO4 potassium 1 K39 manganese 1 manganese, so 1 into 55 plus oxygen 4 into 16, total 158 gram per mole. So how many electron is required? 5 electron. So number of moles of electron 5. So 158 divided by 5 equal to 31.6 gram per equivalent. So the previous slide we have seen the gram equivalent mass of displacement hydrogen, and the next acid, thereafter gram equivalent mass of base, at last we have seen redox reaction. Okay, the question number 7. How do you calculate equivalent mass in the basis of mole concept in the following equation? Here the equations are given, but it is not redox reaction. It is a balanced equation. So mole concepts are applied, but here itself we can find the gram equivalent mass. So how to find it? So by the equation we should know that 2 moles of potassium permanganate reacts with 10 moles of ferrous sulfate. 2 moles of potassium permanganate reacts with 10 moles of ferrous sulfate. So potassium permanganate total atomic mass 158 multiplied with 2 moles, 316 gram of potassium permanganate reacts with 10 moles of ferrous sulfate. Ferrous sulfate atomic mass 152, so moles 10, 1520 gram. It is anhydrous ferrous sulfate. So now we have to find the gram equivalent mass of potassium permanganate. Okay, actually what is the meaning of the calculation? 316 gram of potassium permanganate reacts with 1520 gram of ferrous sulfate. If so, 31 gram 31.6 gram of KMnO4 31.6 gram of KMnO4 reacts with how much mass of ferrous sulfate? How much mass of ferrous sulfate? I repeat again, 316 gram of potassium permanganate reacts with 1520 gram of anhydrous ferrous sulfate. That is required. If so, 31.6 gram of KMnO4 reacts with how much mass of ferrous sulfate is required? That is called equivalent mass of KMnO4. Equivalent mass of KMnO4.